Hi everyone, today we are going to start 5.3, which is use angle bisectors of triangles. Angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So if we look at our diagram here, ray JK is an angle bisector of angle LJM. So this red ray here is ray JK. It bisects or cuts in half this large angle, LJM, meaning that this angle is then congruent to this angle. Angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So what that means is that if a point, such as point D, is on the angle bisector, then it is equidistant. So this segment would be congruent to this segment from the two sides of the angle. So if we look at our statement here, so if AD bisects angle B and BD is perpendicular to AB and DC is perpendicular to AB, then DB is congruent to DC. So the perpendicular parts have to be here and here. So once again, if we have an angle bisector, this point D is going to be equidistant from the other edges of the angle, as well as perpendicular with our angles here. The converse of the angle bisector theorem states if a point is in the interior of an angle that is equidistant from the sides of the angle, then it lies on the angle bisector. So if we do not know AD is an angle bisector, but I see that D is equidistant from one side of the angle as well as the other side of the angle, as well as makes a 90-degree angle, I therefore know that AD has to be an angle bisector. So use the angle bisector theorem. We want to find the measure of angle GFJ. All right, so two things we need to look for. One, do we have perpendicular lines? And we do because we see these 90-degree angles. We also want to see, is J equidistant from point G and H? And the answer is yes. 7 and 7, those are the same length, which means J is equidistant from the sides of the angles. Therefore, JF is an angle bisector. So if this angle here is 42 degrees, what is the measure of angle GFJ going to be? It's also going to be 42 degrees. For what value of x does P lie on the bisector of angle A? All right, so P must be equidistant from point B and from point C to be on the line of the perpendicular bisector. I do see 90-degree angles here, so that's good. So which value of x would make this lie on point P lie on the angle bisector? Well, I would just need to set these two equal to each other. So x plus 3 is equal to 2x minus 1. Let's solve for x. So I'm going to subtract 1x from each side. So 3 is equal to x minus 1. Add 1. So 4 is equal to x. And I can double check that this is correct by plugging x back into my equation. When I do so, I end up getting that this is 7 and this is 7. They both are the same, which is good, meaning I found my correct x value. All right, we're going to do the same thing again. So in these exercises, find the value of x. All right, so looking here at this ray, I notice that these two angles are the same, and I also see I have perpendicular lines. So that means I have an angle bisector. Angle bisector cuts an angle in half. So if this segment is 15, what should x also be? It's going to be 15. Looking at number 2, I see that I have a ray here I also see that I have perpendicular lines creating 90-degree angles. These two segments are congruent, meaning that that ray is a perpendicular bisector. So these angles then are going to be congruent. So I'm going to set those two equations equal to each other. So 3x plus 5 is equal to 4x minus 6. I'm going to subtract 3x from each side. So 5 is equal to x minus 6. I'm going to add 6, and I end up getting that 11 is equal to x. And let's double check that our x value is correct. If I plug x back into my equations for my angle measures, I end up getting that this angle is 38 degrees and this angle is 38 degrees, which they should be equal to each other since it was an angle bisector. So I am correct. All right, next one, number 3. Same thing, I want to solve for x. So looking at my diagram, I have a ray here. I notice that my angles are the same, as well as a 90-degree angle here, meaning those two lines are perpendicular. That means that this ray is a angle bisector, so these two segments are congruent. So let's set them equal to each other. All right, so I'm going to subtract 5x from each side, so that 0 is equal to x minus 5. Then I'm going to add 5, so 5 is equal to x. Now let's double check that our x value is correct by plugging it back in. And when you do so, you end up getting that this is 25 and this is 25. Those are congruent, and we found the correct answer. Looking at this diagram, do we have enough information to conclude that ray SQ bisects this angle, angle PQR? All right, so let's look at our diagram here. So our angle, the only thing we know here is that S is equidistant from P as it is to R, because we have those tick marks there. So is there enough information? The correct answer is no. We would need to establish, or we would need to know that segment SR is perpendicular to segment QR. So SR to QR, we would need a 90-degree angle here. And we would also need to know that SP was perpendicular to QP. We would need to know that this is a 90-degree angle there. Or we would need to know that these two angles are congruent. So we would need to know that angle QS would be congruent to angle RQS. So because we don't know all that, we cannot conclude. Concurrency of angle bisectors of a triangle. The angle bisector of a triangle intersects at the point that is equidistant from all sides of the triangle. So that means that if AP, BP, and CP are angle bisectors of triangle ABC, then we know that PD, which is this segment right here, PE, which is this segment right here, and PF, which is this segment here, are all congruent. They're the same length. So that's going to be important in future lessons. So point P is going to be the collision of all the angle bisectors. That's called the incenter. This is another vocab term that you will want to know. So the concurrency of the angle bisectors is called the incenter. Please write that in your notes. All right. So point G is the incenter of triangle ACE. We want to find BG. So BG is this segment right here. Oops. All right, so point G is the incenter. What would BG be equal to? Well, we know from our last slide that these segments are all congruent. So what is the length of BG? Well, BG is going to be equal to 16 because it is congruent to segment FG. Next, let's review Pythagorean theorem. A squared plus b squared equals c squared. Remember, we use this for right triangles, and c is always going to be the hypotenuse, which is always opposite of the 90-degree angle. So if I draw a 90-degree or a right triangle, our hypotenuse will always have to be here. And then A and B are just the legs of the right triangle. It can be either or. You can flip those around. It won't matter. The only one that's very important is C. It has to be the hypotenuse. All right. So let's work on question number 14. So point P, which is right here, is the incenter of triangle HKM. We want to find JP. All right. So I see that this segment here is 24. I see that this segment here is 25. I'm looking for this segment right here, JP. Well, I know that JP and PN are congruent. They're going to be the same length. So I'm actually going to work with NP for right now, because if I look at what I highlighted in purple, I have a right triangle. So let's redraw this. So here's my 90-degree angle. This is 25, this is 24, and this is X. If I figure out X, I will then know what the length of JP is, because I know that X and JP are congruent. So looking at my triangle, I'm going to need to use the Pythagorean theorem to solve for X. So here we go. A squared plus b squared is equal to c squared. I'll call x a. So x squared plus b is going to be 24, and I'm squaring that, is equal to c, which has to be 25, because 25 is our hypotenuse. All right, so let's simplify this. I end up getting that x squared plus 24 squared is 576 is equal to 25 squared, which is 625. All right, then I'm going to subtract 576 from each side. So x squared is equal to 49. But remember, I don't want x squared, I want x. So I have to do the square root of each side, which means then that x is equal to 7. So if x is equal to 7, I then know that JP is also equal to 7. And here is our challenge problem of the day, number 15. So we want to make the value of x that would make n the incenter of this triangle. All right. So if n would be the incenter, I know that these segments are congruent. Okay. Well, if I look at what is given, I know this length, I know this length, but I do not know this length of this right triangle. So let's solve for this x value. All right, I'm going to redraw my triangle. So I have x. This is going to be 52, and this is 48. So I just redrew that purple triangle so I can see it better. All right, so a squared plus b squared is equal to c squared. Let's solve for x. X is going to be a, so I'll call this a squared. B is going to be 48, so I have 48 squared is equal to c squared, which c has to be 52 because that's my hypotenuse, so 52, and I'm going to square that. All right, so x squared is just going to stay as x squared. 48 squared is 2,304. 52 squared is 2,704. If I subtract 2,304 from each side, I end up getting that x squared is equal to 400. I don't care about x squared, I care about x, so I need to do the square root of each side. So x then is equal to 20. But I'm not done, because it said what value of x would make n the incenter. I have x here. So I made up an x here, but I want to know what this x is going to have to be to make n the incenter. So if m, Yeah, so mn is equal to 20, which we want it equal to 4x, right? So if I solve from x here, 20 is equal to 4x. I end up getting that 5 is equal to x. So the x that's in my problem, not here, sorry, I probably should have used a different variable, but x that was in my problem from this here, I end up getting that x is going to equal 5.